It's a really pleasure to be here and especially open the first session on quantum technologies. So let me start. Let me start with some first citations about quantum technologies. You can find like revolutionary impact, global strategic importance, decisive advantage, or significant altered contemporary conflict. So let me, in the following few minutes, to guide you what's behind these citations. So what's quantum technology? For me, because my original training is in nuclear physics, it's a very exciting field of physics. However, it's also a field where we can see very strong dynamic between fundamental research, applied research, and let's say commercial development. I have never seen in any other field where, let's say, big giants like Google, Microsoft, Amazon would put billions in fundamental research for developing some Majorana qubits. So, as you saw on citation at the beginning, there are also strong governmental and also commercial interest. And indeed, it's a technology suspicious with potential impact for our society and especially security. And as every technology, there can be positive as well as negative surprises or risks. So don't worry, I will not speak about much quantum. So this is only my slide about quantum. So what's behind the quantum is the, let's say, technological level where we are able to manipulate with individual quanta. We can really hold individual electrons, atoms, and we can manipulate them. And at this level of quantum mechanics, we can then exploit some properties like entanglement, superposition. We can manipulate with energy levels. And thanks to it, we are able to reach up to exponential speed up in computation, just for some tasks, not universally. We can create super secure communication that is not possible to eavesdrop. Or we can have much better sensors and imaging systems. So it's good to divide quantum technologies in, let's say, three big fields, because everyone's speaking about quantum computing, and we already heard about that, these words today. But quantum technologies is not only quantum computing, but for sure, quantum computing is interesting because from security perspective, when we will have capable quantum computer, it will be able to break our current encryptions. But also it will be very interesting for chemical simulations, designing new materials. There is a lot of investigation how quantum and AI could work together. But there is also quantum communication. For example, quantum key distribution. I saw that in the other room there are 2 booths at least about quantum key distribution, so you can learn for sure more there. And you know, it's very unlikely we will have one big quantum computer. In reality, we will have several smaller quantum computers which will be interconnected through quantum networks, so quantum communications. And if we move to quantum sensing, it's even actually a very rich landscape where you can use quantum sensors for sensing different properties like magnetometry, inertial forces, and you can have potentially very different application, especially in security and military. I created this picture like 4 years ago as illustration how people consider how quantum technologies could be used in, let's say, warfare domains. Today, after 4 years, still it's unclear what all could be realized and what's some level. We are a bit more smarter today. For example, quantum radar, especially very supported by Chinese media, like, hey, your stealth planes are not anymore stealth, but actually in reality it's not so true. Quantum radar is something that is not feasible or reliable for, let's say, military application, at least not with current technologies. But there are in other aspects, like, for example, quantum navigation, that is reality already today. So I would like to take you through some examples for last year. So you can see it's just selected research activities for last year, so, and only in military domain. So you can see it's a pretty increasing topic. So military dual use, and especially for last year, I can see increasing number of scientific papers on quantum computing applied for military applications. So now I would like to take you through a few use cases. So first, the most famous is ability of quantum computers to break current asymmetric encryptions. That's pretty problematic because asymmetric encryptions we use for most of the communication around us, so all internet, in most cases, is asymmetric encryptions. Of course, at a super, let's say, secret level, classified level. For example, intelligence, they use different systems, so they are relatively okay, but all other is in danger. The question is when it will be relevant. Actually, it's relevant today because we already know that some adversaries, they already collecting encrypted data, public key, and they will just wait when quantum computer will be available, and they open, and in case there is some, let's say, secrecy that it should be secret more than 10 years, considering that in 10 years we will have quantum computers, you have problem already today. But fortunately, we already have some solutions. One of them is post-quantum cryptography, which is actually not in quantum. It's just, let's say, new math, new algorithms, where we believe that it is, let's say, resilient to quantum attacks as well as attacks by classical computers. Alternatively, we can consider quantum key distribution, which is a purely quantum, let's say, system that we mathematically can prove. You cannot break it if correctly implemented. However, also it means completely or mostly new infrastructure compared to post-quantum cryptography, which can be very often just a, let's say, software upgrade. Another interesting applications use case is about quantum communication infrastructure. At the moment, I have two examples from China, where they are very advanced, over 2,000 kilometers on the ground, already second generation of quantum satellites up. In the EU, we are really in process of constructions, where each member state is building their national quantum network. I saw there is about CAT-QCI, which is exactly the Austrian contributions to these European quantum networks. And hopefully around the end of year or beginning of next year, we will have first European quantum satellites up. What's very interesting today is that this is designed for this quantum key distribution. It's just one service. But in the future, we will be able to upgrade to something we call quantum internet, which will be able to offer you more services, let's say for this connection quantum computers, but more technical services like distribution or more precise timing, because quantum clocks, another very interesting application, is so precise that current technology is not able to distribute this, let's say, precision in time. Another interesting applications, it's actually this situation in Ukraine, it's a big school for us. Especially in electronic domain, it's extremely challenging environment. And for example, from navigation, you know, most of you rely on satellite navigation like GPS or European Galileo. And, you know, due to jamming, it's not available or it's not reliable. So here, quantum can help pretty much. At one level, we have something that is we call quantum inertial navigation. So it's a measure how you accelerate, how you rotate, and calculate where is your position. This, at the moment, let's say, is tested in a relevant environment, but there is not, let's say, complete system, at least not in a public domain. Another application is that is based on quantum magnetic navigation, because Earth is not homogeneous. There is a lot of magnetic anomalies on the surface of the Earth. And if you create this global map of these anomalies, and then you perform local measurements, you compare these two magnetic signatures, and you can estimate your position very precisely. There are even already two commercial solutions, especially the second one from Australia, from Q-Control, is proven is better than classical inertial navigation system. So that's something that we will be able, let's say, deploy in 1 to 2 years. And it's already pretty small, so you can expect soon to be deployed on drones. Interesting application, if I remain with quantum magnetometry, I like these examples of, let's say, ongoing research. One of them is from Germany example, where they study if you know, this quantum magnetometers, it's very sensitive with good resolution. So idea is that you can place it on, let's say, cryptographic chip, and it can see inside what circuits are active, and let's say see what is computed, for example, some key. So that could be a kind of new side channel. Second example is from the US. It's exactly opposite. They use this sensitive magnetometry to see, if there is some defects at the nanoscale dimensions, or if there is something that should not be, because most of this manufacturing is outsourced. So in principle, someone can put very small addition that can, at the end, can serve as a backdoor. And the last example with magnetometry is this magnetoencephalography, MEG, sorry. It's a brain scanning. It's very interesting. It's technologically, it's something that already exists, but it's huge with cryogenic system. But this is small. It's kind of like helmet, and it's with good resolution. So actually, it's pretty good candidate for future brain-computer interface, at least in sense of reading. So, but at the end, quantum technologies will not bring new weapon or complete military system. Actually, it's more better to say, I prefer to say like it will, let's say, make sharper of this system. It's more appropriate to speak about the framework of quantum plus X, where X can be space, because a lot of sensors you can place in the space, including quantum communication. Quantum plus AI is a big topic. Still, let's say, unsure what a big impact will be, but from scientific perspective, it's extremely active. Quantum plus autonomy, so better navigation system, and so on. Chemistry, biology, new materials like designing better stealth or more durable armory. So let's move, let's say, at the higher level to, let's say, international security. So, historically, international security is dealing very much with this, let's say, nuclear weapons, world balance, strategic stability. So from this perspective, in case of quantum technologies, it's not a question if there will be impact. The question is only how big. And to be honest, it's a relatively still big gap in research. In sense, we are still not sure how big impact will be. I have some examples. For example, this nuclear submarines. At one site, you can use quantum magnetometers, and it seems they will be able to make the sea or at least shores more transparent. But actually, not so much like what we have today. But at the other side, this inertial navigation or magnetic aided navigation for submarines, they allow to be longer, deeper in the sea, because today they have quite often they have to go up and synchronize their position with the GPS. So it's a kind of game cat and mouse, and still it's pretty unclear what will be impact. Moreover, for example, in case of US and China, they are relatively at the same level of R&D in quantum. However, there are other countries that they have nuclear weapons. They are not extra friendly. One of them invests heavily in quantum, other not. So the question is, can be their impact? It's very difficult to say. It can also impact quite significantly something we call C4ISR. The whole meaning is there. So it's a whole system where quantum can help to collect all information, collect all data, securely to transfer them, and maybe in long future use quantum computing for processing them. And at the end, it can, let's say, accelerate this loop for faster decision making. And we also already see in Ukraine, fast decision making is pretty important. Also, there is this Q day, so it's the moment when we will have this big quantum computer able to break the classical encryptions asymmetric. So that's a pretty big. At some level, more advanced countries, they are already working on it. There are recommendations, and there are already some deadlines. But also, question is how it's with, let's say, more developing countries. If they will have capacity to go to enough fast to, let's say, some post-quantum solution quantum safe solution. And if not, there could be even bigger disbalance because, let's say, more advanced countries can easily read their encrypted systems. And by time, up to now, I spoke mostly about military systems, which are used by militaries. But of course, with every technology, by time, it will be cheaper, it will be more available, and we can ask what non-state actors could do with that. It's again a big research question. And one very beautiful example, there is, open source or open hardware approach is pretty popular. It's helping to democracy, but also it allows you to already today to build your own quantum magnetometer for $150. And of course, it can be misused. So from perspective of governments, very interesting question is if quantum technologies could help us with some in arms control. That's a pretty interesting possible application. For sure, quantum technologies are not under the arms control like themselves, but it's already a big topic in sense of export controls. It's a part of the Wassenaar Agreement. There are a lot of individual actions. And it's not only, let's say, export, but like of some products, but also already at the level of knowledge, expertise, something we call research security. So there are other regulations. We don't have much time, but for example, dual use something. No, we will not do anything to dual use, but this time is changing. Even European Investment Bank changed their own rules that they can invest in quantum dual use applications. And the cybersecurity I mentioned, some countries, they already have some deadline when you need to be quantum safe. In case of EU, there is a lot of activities, but no, not deadline yet. So quantum is pretty complex. In most cases, one country cannot do all. So we can see a lot of activities. Many countries, they are building their own national strategies. I have to mention that EU soon, next month, should present their own quantum strategy. NATO has their own quantum strategy. And also, quantum technologies are subject of a lot of bilateral relations, especially from the side of the US, but not only. But we have very beautiful examples of multilateral cooperation, especially here in EU, through quantum flagship and other programs. But another example is, for example, AUKUS. This is alliance of Australia, UK, and US, where a significant part of research is dedicated to quantum. Also, we can see increasing activities within BRICS, especially led by China and their, let's say, first place in quantum communications. So at the end, I would like to say, okay, quantum technology is not just fundamental research anymore. It's something that has a lot of potential military applications. It's a typical dual-use technology. For sure, already today, geopolitics impacting quantum technologies, and vice versa, if not yet, really, very soon. And lastly, I would like to invite you to read our paper from CIPRI, kind of introduction for policymakers that could be interesting for you. And thank you. So this was quantum in 15 minutes. Thank you.